So lead code problem of the day, and here I bring the solution for your question. In this video, I will be solving the question called as Seat Reservation Manager. Most interesting point that is I will be solving in a clear concept way. So I highly recommend you to watch this video till end so that you can come across detailed solution as well as the concept we are using to solve this question. So without wasting time, let's get started. So what does the question says that we have to design the system that manages to reserve the state of n seats that are numbered from 1 to n. So what does the question says that we have given a seats from number 1 to n, and what we need to do is we need to first book the seat before you try to sit on any of the seat number. And in order to do this, there are the three things that we need to look after. The first thing is set manager. So what does this function do is it simply initialize the object before you try to book any kind of seat. What does it simply says that there will be n seats which can be 5, 6, 7. So first it will simply initialize its object. Now second thing, that is int reserve. So what does this says that in order to sit on any seat number, first you need to book it. Say for example, I have the seats as 1, 2, 3 and 4. So say for example, I want to sit on number 3, but before you try to sit on number 3 seat, you need to first book it. So simply book it and then try to set it. But the point is, before you try to book any kind of seats, what does the question simply says that we need a smallest number unreserved seat. So there are the 4 seats available for us, and we can book any of the 4 number. We can book 3 or 4 or 1. We can book any one of them. But the point is, they have clearly stated that we need a smallest seat. So which one is the smallest? 1. Is it available for us? Yes. So simply book 1. Now 3 seats are available for us, 2, 3 and 4. Now the question comes, which one is the smallest one? 2 is the smallest, so simply book 2. In this way, we need to book a smallest seats available for us. Smallest seat that is available for us. And void unreserved. So what does it simply say that? Say for example, seat 1 is already booked. And now we need to make it unreserved so that it becomes available for the next person. So that's the reason why unreserve it and make it available for the next person. So that whenever if in case we need to reserve the book in future, that seat is available for us. So I hope so you understood the meaning of the question. Now let's try to check what will be the sample input output for our question. So this is the sample input output question. So we have given the n number of seats, that is equals to 5, right? 5 seats are available for us, which are number from 1, 2, 3, 4 and 5. And first they have asked us to reserve the book. So but the point is, there are the 5 seats are available for us. Now there are 5 seats are available for us. But what does the question says that we need a smallest seat number. Therefore first we will reserve 1. So I have reserved 1. This is done. So again we need to reserve the seats. So there are the 4 seats available, but which one is the minimum? 2 is the minimum. So I will simply reserve a 2. Now I need to make it unreserved 2, which means the 2 is already been booked. Now I need to make sure it is unbooked so that it becomes reusable in the future. So I simply make sure 2 is available for us now. 2 is available for us. Again I need to reserve. Now which one is the smallest? 2. So I'll simply reserve 2 book. So 2 is been reserved. So again we come across the reserve. So I'll reserve as 3. Again at reserve. So I'll simply reserve as 4. And again reserve. So reserve as 5. Now none of the seat is available for us. But what does it mean is all the books are set. All the seats are already booked. Now I need to make sure I unreserve 5. So my seat number 5 is available for me. So I hope so you understood the sample input output as well. Now let's try to derive the intuition to solve this question. So we will be using the heap in order to solve this question. Now the question comes, why do we need a minimum heap? Because what does the question say that it is clearly mentioned in the question that we need a smallest number first to book the seat. Even there are many seats are available for us, but we need a smallest number first. Smallest number first. That's the reason why we need a minimum heap. But the point is, why can't we use the array and simply sort the element and then try to fetch a minimum possible number? The problem with this is, let's say for example, I have 1, 2, 3 and 4. So this number is present in my array and I have sorted in increasing order. Now say for example, I have booked 1, I have booked 2, I have booked 3. Now pointer is pointing at my 4. My index is at 4. Now what they have asked us? They have asked us to unreserve a 2. So what I will do is, my 2 number seat is available for me. Now again they have asked us to reserve the seat. And what does the question says that we need a minimum seat number in order to book any kind of seat. So 2 and 4, 2 seats are available for us. But which one is the minimum? Which one is the minimum? 2. But the point is, my pointer is pointing at 4. So again we need to start traversing the array from the first in order to know which one is the minimum seat available for us. That is the reason why we are not using the array in order to know a minimum seat. Because every time when you unreserve the seat, again we need to traverse that array from first in order to know a minimum possible number. Therefore, we are not using a array and sorting it. This is the reason why we are trying to solve this question using min heap. Now the question comes, why min heap? Say for example, I have the number 1, 2 and 3. So what does a minimum heap says that? My minimum number will be always present at the top. So how does this will look like? It will be 1, then as 2, then as 3. Now suppose I want to insert 0. I want to insert 0 number. Now where the 0 will get inserted? Since 0 is the minimum of all, therefore automatically 0 will be inserted at the top of the 1. So we can simply say that no matter what element you are trying to insert, no matter what element you are trying to remove, always smallest number will be available for us. This is the reason why we are using a minimum heap. Now let's check how we can derive the solution for this using the min heap. Now, therefore, we are given a 5 seats numbered from 1 to 5. It is already mentioned in the question. Now suppose we need to reserve, unreserve 2. Again we need to reserve, and need to unreserve 3. Now let's check out how we can derive the solution using the min heap. So what I will do is, there are the 5 seats are available for us which are numbered from 1 to 5. So 1, 2, 3, 4 and 5. These are the seats available for us. So first they have asked us to reserve it. Okay, I removed 1, which means my smallest seat has been removed. Now which one is the second smallest? 2. As you can see that automatically my heap is getting sorted in such a way that my minimum number will always be present at the top of it. Now again I will reserve. So 2 will get removed. Now suppose they have asked us to unreserve 2. Now I want to insert a 2. Where I can insert a 2? Even if I try to insert a 2 over here, what will happen? It will internally get arranged in such a way that minimum number will always come at the top. Therefore, again my 2 will come at the top of my 3. So this is done. Now again I need to reserve it. So simply which seat I can reserve? Simply I can reserve the 2. Because in question it is clearly mentioned we need a minimum seat first. So I reserve minimum seat first. So this is done. So again we need to reserve. So I reserve 3. Right? I reserve 3. Again I need to reserve. So I reserve 4. Again I need to reserve. I reserved 5. Now what they have asked us? They have asked us to unreserve 3. Which means my seat number 3 is available. So this is how the seat number 3 is available for us. So I hope so why we are using the minimum heap, so that we can solve this question. Because every time whether you insert an element or we remove an element, minimum element will always be present at the top of my minimum heap. So I hope so you understood the intuition behind this. Now let's try to check what will be the C++ and Java code for problem. So this will be the C++ code and this is the Java code. You can check according to your own convenience. So first of all, what we did is we declared a minimum heap, that is priority queue, and the same thing we declared in Java as well. So first of all, I inserted all the seat number from 1 to n, so that my minimum seat will always come at the top, as we discussed in my dry run. Right, now say for example I need to reserve the seat. So what does the question says that we need a minimum seat number first, which is where it is present at the top of the tree, at the top of my min heap. Right, see, my 1 is present at the top, so simply I took the element from the top. Same thing I did over here, simply I pull, which is means element present at the top of my minimum heap, and I simply removed it. I simply removed my 1, which means my 1 number seat is not available, which is already booked by someone. And simply we return the seat number which is already booked, that is the top of my min heap. Now suppose I want to unreserve any seat, unreserved 2. Here we checked, we need to unreserve seat number 3. Again we inserted 3 in my min heap. So this is what we did. We simply inserted a number in minimum heap. And where does it will come at? Again it will internally get sorted according to its own order, because min heap minimum number will always come first, second minimum, third minimum, fourth minimum. So I hope so you understood this question clearly and precisely. Just in case if you are new to our runtime error, do subscribe the runtime error so that you can get a daily solution on LeetCode problems. Till then, I'm signing off.